finally, we're actually putting stuff together now. This is the first component we're going to be working on for my gaming computer from scratch, from the circuit level. Say if we want the computer to remember this input pattern, but we also want the computer to remember this input pattern too. Manually, that would take a lot, just turning on, off, or we need to find a way on where we can store all this data into one big house. This is where memory plays a role. So we need a way for a computer to remember previous data so we can use it for later. This is going to be very, very helpful for while we build our CPU from scratch. Because the computer can't rely on someone switching on and off every single time. A CPU needs an automatic way to store and use data for later. There's a component called the SR latch. And the SR latch just means on and off, set and reset. So we're going to turn it on. And it remembers that data. Now we're going to turn it off. And it remembers that it was off. So it's just using these clever ways to save memory. Alright, so basically I'm making a memory circuit called a D flip-flop. So I have finished the circuit. It has an input, a clock, and a clear button, which is going to be very helpful. The input button just tells it if you want to input data. The clock is just like, are you ready? It's like a double check. So once I hit the clock button, the data will save. Let's put this in a small chip and let's clone this 8 times so we can have 8 memory cells. Actually, I'm going to make it allow system to control if data can come in or come out. And what we're going to do is combine them into one circuit. So we're going to have to connect a few cords together. Okay, nice, it's done. Okay, now we can store 8 bits of data at one time. Okay, we connected all the main power buttons together, and now we're gonna make it into a chip and call it a register. Okay, what we're gonna do now is pretty fun. We made it into a chip, and now we have to connect a bus, which basically, think of a bus as a highway for data to flow through. Okay, now we're connecting the data bus into the input of the registers, and we're going to clone 15 of these chips, think of them as separate homes with the address on it. So say if you wanted to send $5 to house 1, and you wanted to send $7 to house 3. And this is the process of making it automatic for the computer to find the correct address and store their data. Okay, now we're going to connect all the buttons together, and now we have to add the power, the right, and the clear button all together to the 15 registers. Okay, so we cannot connect the right and clear wires directly to the register, so we have to find a way or make a chip, and that prevents the computer from clearing all data. And we're going to make a really tiny double AND gate chip so the computer can pick what address it wants to write to. No, it's okay, we're going to connect the right wires and the clear wires to the small chip we made. Okay, perfect, let's test it out. Okay, we're almost done. We're legit almost done. Okay, now we added a decoder, and this allows the computer to select which register it wants to write or clear to. And we're going to connect the output of the decoder into this small little AND gate select chip. Okay, now we're 90% done. Now we need to get a little messy and connect all the output of the registers into a data allow system that allows the data to flow or not flow. If the computer wants to read something, it can output the data. Okay, please don't make fun of my wiring. I didn't know what was a good or better way to wire. Okay, we're done. Let's connect the output from the A bus and the B bus so it can be a dual read so we can read 2 things at one time. So let's make this whole thing into a chip. Okay, let's test it out. So we have colors right here to demonstrate what the buttons do. So the clock. The purple button is just me the address you want the computer to write to. So let's put the number 100. Let's tell the computer to write to address 1. And let's see. We clocked it, so let's see if it works. Okay, now let's tell the computer to write 19 to address 2. So let's write, clock, and let's display address 2 on the second screen. Okay, looks pretty nice. Now let's just write 2 on address 3. Now let's open address 3. Okay, and it remembers, so, okay, let's put all these numbers and put it to the last address. We do want to test that. Oops. Let's clock it. There we go. So the computer can remember anything, guys. I'm very happy with the results. Okay, I'm so happy. We're done with the first part. We're done with the registers for the CPU. And we're going to be working on the ALU tomorrow. And it's going to be really cool. Okay, bye-bye.